Hey guys, today we're starting a new section. It's section 5-5 on congruent triangles. And there's three things that we're going to take for notes, and then I'll do some examples for you. So take these notes in your math journal. Okay, the first one is side, side, side postulate, and it's also known as SSS. And hopefully you remember this from 10th grade. But it says if three sides of one triangle are congruent to three corresponding sides of another triangle, the triangles are congruent. And I'm going to draw you a picture so you can see what this looks like. So if you need to pause and finish writing this down, go ahead and pause. So what this would look like is if we have these two triangles. I'll try to draw them so they look sort of alike. And then their sides are marked like this. Okay, so that is the side, side, side postulate because it says if the three sides on one triangle are congruent to the three sides of the other corresponding triangle, then the triangles are the same size or congruent. Now remember, congruent means same shape and same size. Okay, so if I want to write that these two triangles are congruent, remember you have to name them the same way. And so what I'm going to do is I'm going to start with the side that has one bar on it and move across to the side that has two bars. So my first triangle I'm going to call triangle A, B, C because I started with that one hashtag and then I moved to the side that has two on it. And then I have to name my other triangle the same way. So start with the side that has one and move around to the side that has two, and I made a mistake there. My bad. Okay, so is congruent to triangle DEF, and this part is going to help you on the IXL because you do have to name the triangles like this. It's a little easier on the other two postulates that we're going to do, and I'll show you those next. Okay, so the next one is called side angle side postulate, and it's abbreviated SAS. And it says if two sides and the included angle of one triangle are congruent to two corresponding sides and the included angle of another triangle, then the two triangles are congruent. So copy this definition down, and I'm going to draw you a picture of these as well so you can see what this looks like. Okay, so side angle side means this side, this angle, and this side. Sorry about that. So the side, the angle, and the side are all next to each other, okay? Like this, side, angle, side. So the angle is between the two sides. That's why it's called side angle side. It's written with the angle in the middle, and the angle is actually in the middle. All right, and so if we want to write this one, we're going to write it like the same way that we did the last one. We want to name our triangles in the way that they are congruent to each other. So if I'm going to start with Q, that means I'm going to go alongside one, reach the angle that they have in common, and then go alongside two. So I'm going to name it triangle QRS is congruent to triangle, and then I'm going to do the same thing on the next triangle. Go along the one side, hit the angle in the middle, and go along the number two side and name it just like that. So TUV. Okay, and the last one we're going to talk about today is the angle side angle postulate. And so on this one, you have two angles that are congruent with a side in the middle. Sorry. So I'm going to start writing the definition. You copy it down and pause when you need to. So on this one, it says if the two angles and included side of one triangle are congruent to two corresponding angles and included side of another triangle, then the two triangles are congruent. So in other words, there's an angle and a side in between. And I'm going to show you what that looks like. Okay, and this is our, we've got an angle, a side, and another angle. Okay. All right, so again, if I want to name this triangle, the two triangles, and show that they're congruent, I have to name them in the same way. So let's start this time with this angle that doesn't have anything on it. We'll go down to the angle that has one loop on it and over to the angle that has two loops on it. And we're going to call it triangle IHJ is congruent to triangle, and so we're going to name this one the same way. All right, so we're going to start with the angle that has nothing on it, go to the angle that has one loop, move to the angle that has two loops. So this one will be called MKL. All right, there's one more that's not in this section of the book. I don't know why, but you will see it on IXL, so I want to go over it quickly. It's called angle, angle, side. And so what that means is you have an angle right next to another angle that's congruent, and then a side is next to those two. All right, so that's angle, angle, side. On page 214, number 1, in the directions, it gives us that triangle ABC is congruent to triangle DEF, and we have these two triangles. And it wants us to name the corresponding congruent parts. So I have to name all the sides that are congruent to each other and all the angles that are congruent to each other. Remember, the way they name the triangles is the way that they're congruent to each other. So what that means in this case is that angle A is going to be congruent to angle D because they're both in the same position when they're being named. Okay, let's keep going. So that means that B is going to be the same size as E because they're both named in the middle. And then the last letter is going to be the same size as the last letter because they're both named at the end. So now we can write those down. We can say angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. All right, so just like the angles are congruent to each other because of the way the triangle is named, the sides are congruent because of the way it's named also. So that means side AB is going to be congruent to DE. And then side BC is going to be congruent to EF. And then the last two sides are going to be your outer and inner. So that means side, oh my goodness. Side AC is going to be congruent to DF. So those two are going to be congruent. Okay? All right. So I'm going to just name those now according to how they are congruent to each other. So side AB is congruent to DE. And I'm just looking at how I marked my triangle now. It's important to draw this out and mark it. If you try to do it all in your head, you're probably going to make mistakes. BC is congruent to EF. and then the outer and inner. So AC is congruent to DF. And that's what they're asking us for in number 1 when they say name all the corresponding congruent parts. We named all the sides that are congruent to each other and all the angles that are congruent to each other. Okay, so on this one, it says state whether each pair of triangles is congruent. If a pair is congruent, name the congruence and appropriate postulate. So we have to name the triangles, and then we have to say which postulate says that it's congruent. So if I look at these two triangles in number 2, I see a side, an angle, and a side, and I know that's one of my postulates. So the way that I can prove these two triangles congruent is by side, angle, side, and then they want me to name it. So remember, you have to name it the same way as you name the second triangle. So I'll say triangle DFE, because I'm going to start at the top, go down. But pay more attention to the angles in the triangle, not just starting at the top, because on IXL they flip the triangles like every different direction. And so you're going to have one that's facing this way and one that's facing this way, and you're going to have to look at the angles to name it correctly. So again, I'm going to start with that angle that has nothing, go alongside number 1, and then go alongside number 2. So I'm going to say it's congruent to triangle GJH. So for number 3, it says, same thing, tell if they're congruent, and if so, which postulate proves them congruent. So here's the thing about this type of triangle. Because they share this center line, it's the same size in both triangles, okay? So we have a triangle with one side equal over here. These two sides down here are equal, and then the one they share in the middle is equal. So yes, it is congruent, and we can prove that by side, side, side. So that's the postulate that proves it, and then we can name them. So I'm going to start with the side that has 1 mark on it and go to the side that has 2. So I'm going to call it angle SRU, triangle SRU. And then on the other side, this is kind of like what you're going to see on IXL. I have to start up here, the side that has 1, and go to the side that has 2. So I'm going to name it STU. Okay, so for the last triangle in this section, can we prove that it is congruent? And when you first glance at it, you think, oh yeah, sure, because 2 sides are equal and 1 angle is equal. But the angle is not between the 2 sides that are equal. So essentially what you have here is side, side, angle, and you can see what that spells backwards. So that is not one of our postulates. There's not enough information to prove that these two triangles are the same size. So if it spells that naughty word, it's not okay, it's not going to work. Okay, the last section just says for numbers 5 and 6, which angle is included between these sides that they're giving us. So they just want to know the angle that falls between. So the first one is which angle falls between AB and BC. Well, that would be angle B. And which angle falls between AC and AB? Here's AC, here's AB. So the angle that's between those two is going to be angle A. I'm almost out of time, so I'm trying to watch my clock. Okay, and then it says which side is between these two angles. So which side is between angle A and angle B? That's going to be this side right here. So I'm going to call it side AB. And then for the last one, which side is between angle B and angle C, that's going to be this side. And